So hi and assalamualaikum and very good afternoon. My name is Fitri Saidatulnisa binti Raman. My matrix number is 207720 and I am from group 7. So my question is the question number 1, which is a company needs to design a cylindrical can that holds 475 cubic centimeters of fluid. What are the dimensions of the can that would require the least amount of material? So, from this question, we can see that the shape we use is cylindrical, which is cylinder. So we have to draw a cylindrical shape like this. And after that, we know the variable we can use in this cylinder is radius r and the height. And after that, from this question we can see the information, which is volume of the cylinder, which is 475 cubic centimeters. So from this value we can build a function, the function of volume, which is pi r square h equal to 475. And after that, continue the question. The question is, what are dimensions? So we know that the function uh, that have to be optimized require the least amount, meaning that we have to find the function that have to be optimized. So from here we know that we can use the area function, which is the variable is radius and the height. So this is the first equation. And after that, we from this function we can see that there are two variables. So we can make it just in one variable, which is r, from the volume function. So we find the h equation, which is the second equation, and substitute into the one equation, the first equation. So after that, we got like this: a equal to 2 pi r square plus 2 pi r multiplied by 475 over pi r square. So we can see here there's only one variable in area function. After that, in order to find minimum or maximum, we have to find the critical point. Okay, we have to find the critical point, which is r. In order to find the critical point, we have to find the derivative of the function, which is the area function. So we find the derivative of a, which is 4 pi r minus 950 over r square. So this is the derivative of a function. After that, to find the critical point, we have to equal the derivative with 0. So we can get the r is, or critical point is cube root 475 over 2 pi. And after that, to know that this critical point is maximum or minimum, we have to test it by first derivative test. So we make this kind of table. So the first row is interval from minus infinity and this critical point, and after until the positive infinity. So we find the second row is sign of derivative. So if we substitute the value in negative side, we can get the sign of derivative is negative, and at positive side is positive. After that, we have to find the behavior. If the sign is negative, it will be decreasing, and if the the sign is positive, it will increasing. So we can see that the R is minimum because it moved from negative to positive. So this is, you can see here, the R is at the minimum. Okay, and after that we have to write the answer to answer the question in a correct way. So the question is we have to find the dimension that will minimize the material use. So we have to show what is the radius and the height. Okay, so this is the dimension that will minimize the material used. So the R, you can see approximately 4.23 centimeter. For the height is 8.46 centimeter, approximately for 8.46 centimeter. And after that, we finalize our answer with this kind of sentences. This is the dimensions that will minimize the material use are when the radius of the cane is r cube root 475 over 2 pi approximately 4.23 centimeter, and the height of the cane is h equal to cube root 1900 pi squared over pi, approximately 8.46 centimeter. So that's all for the first question. For the solution, thank you.